Let's take a look at number 15 from the kinematics test. And in case you just want to check things on your own, I'm going to scroll the test up here so you can go back and forth and figure out the parts that you need help with. But in case you want to hear me go through the whole thing, that's what we're going to do now. And so read the problem, get familiar with it, and then hit go again and listen to me explain how we do this. And so train A is starting from rest, has an acceleration of 0.5, and I'm going to place it at the origin. And so those are its vital statistics. And the first question is how much time until it's going 40 meters per second, which is the constant speed of train B. And so this tells me my velocity is a function of time. I solved that for time. The final is 40, the initial is 0, the acceleration 0.5, 80 seconds. Second question, how far has each train traveled in this time? Just how far have they gone? So you can do this big fancy equation here. X is my initial position plus my initial velocity times the time plus 1/2 at squared. And the initial position and velocity are 0, so it's just 1/2 at squared, 1,600 meters. And for train B, you can do the same thing, but that's even simpler. There's no acceleration, no initial position that we care about because we just want to know how far we went, not where we're at on this coordinate system. And so it's just 40 times 80 or 3,200. Another way to do it is just the average velocity times the time is the distance, and you just have to watch it because the average velocity of train A is only 20. It starts at 0 and ends up at 40. The average of B is 40. And that gives you the same answers. And then a little tougher, at what time did the trains collide? And so we need to write an equation for each train. And we use the equation that we have up here. And you just carefully substitute everything you know. And so train A's position at any time in the future before the crash is where it started. I have it starting at the origin. Its initial velocity times the time, which is 0, 1/2 at squared. So this equation tells me where train A is at any time. Same with train B. Its initial position, though, is 6,000. Notice I drew a picture. If you didn't draw a picture and you had trouble with this one, that would be a good idea. I place the origin at train A, and I put train B at 6,000 meters in the positive direction. And so train B has a negative 40 meter per second velocity, no acceleration, and an initial position of 6,000. And so if you didn't draw a picture and you had trouble, that is why you had trouble. And so we write that equation also for train B. And so 6,000 is the initial position, minus 40t, and acceleration 0. So that tells me where train B is at any time. And what I want to do is find the intersection of these two lines. And so I'm answering the question, when does XA equal XB? So I set the two equal and write it out as a quadratic and solve the quadratic, and I get 94.35 seconds. How far has train A gone at the time of the collision? So I just take this time and put it back into my train A equation, and I get 2225.5 meters. They didn't ask for this, but if I put this time into the train B equation, I get essentially the same answer, so I know I'm right, so yay. And which train has the greatest speed at the time of the collision? And so the question is, did train A end up going more than 40 meters per second? Because train B was always going 40. And so you can find that out by just multiplying the acceleration times the time. And yes, it's going a little bit faster, and so train A. So give this one a look. And if you see stuff like this on the final, good luck.